Okay, Newton's laws. If you're going to do dynamics and be a dynamics expert, you got to understand Newton's laws. These govern pretty much everything we're going to be doing. So, Newton's first law, he's got three of them. An object at rest remains at rest unless acted upon by an external force, and an object in motion remains in motion unless acted upon by an external force. So, things will tend to stay in whatever state they're in unless you put energy into or you exert a force onto that thing, right? If you have a box and the box is just sitting on the ground, the box isn't just going to spontaneously start moving, right? It's impossible, right? You need to push it, right? You need to put some energy into the box or some force into the box to make the box move, right? It's not going to move on its own. If we have a baseball flying through space and there's no external forces acting on it, it's going to continue moving at whatever its initial velocity was forever. In that direction, one direction, same speed for all of time, will just continue at that state. Equivalently, if it just wasn't moving in absolute space, it just won't move until some force is imparted onto it. So why do baseballs stop on Earth? Well, baseballs stop on Earth and they don't go on forever and ever and ever because we have aerodynamic drag, right? So there's a drag force opposing the motion of the ball, and there's also a force pulling the ball towards the Earth called gravity, right? So eventually the ball is just going to hit the ground and roll to a stop. Newton's second law. So Newton's second law says that the force is equal to the rate of change of this product mv. And this mv is called linear momentum. So the force is directly proportional to the rate of change of linear momentum. And if our mass is constant in the system, well, then if this is constant, we know we can take it outside of the derivative, right? So m is now on the outside. And what's the derivative of velocity? Acceleration, right? So we get the one everybody is usually pretty familiar with, this F equals ma, right? I think some textbooks kind of yell at you if you just say it's F equals ma, and others say, it's the rate of change of the linear momentum. This is what it is, but you always see it as F equals ma. What's an example of something where the mass isn't constant? Well, you could have a rocket, right? A rocket is constantly using fuel, and it's throwing that fuel out the back of the rocket. So the mass of the rocket itself is changing, right? And there's a bunch of special equations that are used for getting a rocket into space. Okay, note, Newton's laws are only valid in an inertial reference frame, right? And we recall what an inertial frame is, right? It's a non-accelerating reference frame. So the reference frame can't be rotating. It can only be moving in a straight line at a constant velocity or absolutely fixed in space. That is an inertial reference frame. So A, our vector A here in our F equals ma, is the absolute acceleration, which is taken with respect to the inertial frame. Finally, Newton's third law. For every action, there's an equal and opposite reaction, right? So if this guy were to push on a wall this way, then the wall is going to exert an equal and opposite force the other way on the guy. Another example of this would be if you are in a rolling chair and you have a bunch of textbooks with you, and then you start chucking those textbooks off the back of you're just throwing them in one direction off of your wheelie chair. You're going to move in one direction and the textbooks are going to go in another direction. That's because the force of you throwing throwing the textbook is exerting an equal and opposite force on you. So there you go. This was a very short video, but that is Newton's three laws. And then this will allow us to start getting into kinematics, which branches off of all the examples we've been doing in So that was Newton's three laws, and that will allow us to start getting into kinetics, where we're concerned with forces, and branch off of what we've been doing before, which was just kinematics, where we didn't really look at the forces or anything. We were just looking at position vectors, velocity, acceleration, but now we can start getting into the kinetics. All right, that's it. See ya.